Hi everybody, this is my second video on using the vector cross product. In the previous video, I showed you how we can derive that A crossed with B is the determinant of this matrix, where A and B are given here. In this video, I'm going to show you how to use this to find the normal vector between two known vectors and the acute angle between two vectors. If you want to work along with me in this video, you can download a copy of a PDF from my website. Okay, so for question A, we've been asked to find a vector which is perpendicular to this one and this one. So if I sketch this as a quick diagram, we can say that this one is vector A, this one is vector B, and by crossing these together, we'll get the vector of this normal, which passes through A and B at 90 degrees. So if we say that this is A1, A2, and A3, B1, B2, and B3, then we can substitute these into this equation. So A crossed with B will be equal to this 3 by 3 matrix. So now we need to find this determinant. So we'll start with the I. We'll cross out this column and this row. So the determinant of this matrix will be 3 times 7 minus the negative 2 times 4. Then we'll move on to J. This will be minus J. The 1 times the 7 minus the negative 2 times the negative 1. And then we'll move on to the K. And this will be 1 times 4 minus the 3 times the negative 1. We can work out each of these, and this will give us our normal vector. So I'll label this on the diagram as 29i minus 5j and 7k. Okay? And then for part B, calculate the acute angle between the two vectors. So to find the acute angle, we need to find the magnitude of A crossed with B, which means we need to find the magnitude of this. And this will be the square root of 29 squared plus the 5 squared plus the 7 squared, which gives us root 915. So I'll substitute this back into here. We need to find the magnitude of A, so we'll do the same for this vector, and this will give us root 14. We'll find the magnitude of B, and this will give us root 66 times the sine of angle theta. And this theta is the angle between the two vectors. So to work out the sine of theta, we'll divide both sides by this, and we get 0.995 equals the sine of theta. So we'll take the arcsine of both sides, and theta will give us approximately 84.3 degrees. Okay, so thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.